Greetings, my name is Sylvester Dylan Anajo, and this is my final year project proposal, which is titled CFD Analysis of Wave Impact on Walls. Alright, so moving on to the project summary, I am going to be using CFD, which is Computational Fluid Dynamics, namely ANSYS Fluent, to study the wave impact on an object. Okay, the objective is to develop a simulation of the impact of the wave that is going to hit the wall. Okay, namely the type of wave I'm going to be studying is a turbulent bore, and I want to see the impact it has on a seawall. Okay, and the types of wall to be studied is a vertical or inclined wall. Um, Different types of wave form different types of heights and force with it, so it's important to study the impact because it prepares us to develop a seawall that can withstand the impact of any kind of wave, especially during the monsoon season. And then in Malaysia, especially towards the monsoon season, having a very steady seawall that is designed properly to handle the pressure of waterways is very important to prevent any uh, disasters. Okay, moving on to the introduction, I'm going to talk about what are coastal seawalls, why do we need to study the wave impact, and what can this study provide. Okay, now a coastal seawall is a wall built at the coastal area to protect the land behind it from waves and high water levels. Okay, extreme waves can occur more frequently, especially nowadays due to the change in climate. And as the planet gets warmer, sea water levels rises, and weather patterns are constantly changing. So it's very important to study the wave impact so that we can build and design a seawall that can withstand the extreme weather conditions. Okay, so doing this study, we can provide information to designers and people who make coastal seawalls so that they are prepared to build walls that can withstand the impact of waves. Okay, now we have the literature review, and I'm going to talk about the properties of water and the boundary condition in simulation. Okay, why is it important to set the properties of water as close as possible to the physical properties of water? This is because it will reduce computational time. Okay, so as you can see, these are the density of water, the kinematic viscosity of water, the density of air, and the kinematic viscosity of air. Okay, now it says here that the inlet boundary condition are used to simulate wave pedal physical motion. So what that means is instead of simulating a wave pedal, designing a wave pedal in the simulation, we just use inlet boundary conditions to simulate the motion. Okay, now air velocity is set as 0 and water is set as at a specific velocity. This is because we want to study the wave impact of water. Okay, air will exit from the top and the right boundaries. So the top is the atmosphere and the right boundary is the outlet. Okay, other boundaries and fixed ratios are set as no slip. This is because we just want to study the wave itself. Okay, in this slide, I'm going to talk about the broken wave impact. So what is a broken wave? A broken wave is a wave that breaks before impact. So why is it important to study this kind of wave? Because this wave has the highest or higher pressure impact compared to other types of wave. Okay, now we're going to talk about pressure distribution. So pressure distribution is actually an integral part in designing a coastal seawall because we need to determine the structural stability. Alright, now usually the pressure of the wall that's facing the wave uh, is higher compared to the rest of the wall. So that's why it's very important to study the wave impact, because if we know how much the pressure is distributed by the wave, we can design a wall that can withstand it and without fail. Okay, now moving on to the problem statement. Okay, coastal seawalls. On a daily basis, they are always bombarded by waterways. Okay, so it's very important to design these seawalls that can withstand the pressures exerted by the waves. So there are usually two kinds of walls in Malaysia, which is vertical and also inclined. So my study is going to help the designers of the coastal sea walls to determine what kind of walls they should design and how big of a pressure are the waters going to impact the seawalls. Okay, these are my objectives. Okay, the first objective is to study the impact exerted by turbulent bores on walls, and the second objective is to study the wave formation of different types of walls. So this is the scope and limitation. So the scope is that the study only focuses on the pressure exerted by turbulent bores, and the study will only focus on the wall aspect. And the limitation is that this is only done in a simulation, and the geometry used for the wall is simple, which means the geometry is just a simple wall without any crevices, pores, or whatever. And also, I'm using a student version of ANSYS Fluid, and there is no access to a higher powered computer. Okay, moving on to the methodology. We have 4 steps in the methodology, which is first is to set up the geometry, second is to initiate the boundary condition, third is to run the simulation, and fourth is to check the results and the discussion. Okay, this is the setting up of the geometry. I am going to be using the ANSYS Design Modeler to design an open channel in the form of a cuboid. As you can see, the bottom left part right here, this part is actually the wall that I'm going to be studying. Okay, this is where the water is going to be on a surface level of the water. This part is going to be the atmosphere, and this is the inlet, and this is the outlet. Okay, as you can see, this is the boundary conditions, and this is the meshing that I have done. So before we start initializing the boundary conditions, we have to mesh the geometry first. Okay, as you can see, the meshing element size is only 0.5 meter, and the maximum mesh size is 1 meter. Now, this is what we call a transient simulation, and the gravitational acceleration is set at a y direction with a gravitational acceleration of negative 9.81 meter per second squared. Okay, this is a multi-phase model with the volume of fluid method. Why am I using the multi-phase model? That's because we have two kinds of fluids, which is air and water. Okay, and the free surface level, which is the level the water is going to be resting, is set at 1 meter right here. Okay, as you can see, this is my geometry after it has been set up and the boundary conditions have been initialized. So what I've done is actually I have created a contour right here to study the wave impact. This contour is what I am going to where I'm going to measure the pressure distribution. Okay, so I'm going to show you how the simulation looks like after it is being run. Okay, as you can see, this is where the wave starts to hit the wall right here. Yeah. Okay, and I'm going to talk about the expected results and the validation study. Now, as you can see right here, the moment the wave hits the wall, as seen by this study, the pressure will spike up to like 0.3 bar, which is about 30,000 pascals. And same goes for this study as well. This is where the pressure spikes. This is where the wave hits the wall, and this part right here is actually just to normalize the chart. It is part of statistics to make the graph looks more smooth. Okay, this is my validation study from what I've done on ANSYS Fluent. So as you can see from the previous slide, where the wave hits the wall, this is where the pressure spikes up. And as you can see, my pressure right here is about 40,000 pascal, which is very close to the ranges which I got from both previous studies. So what I can say from this is that my research is done very well, and it is actually quite close to the previous studies. Okay, that is all from me. Thank you so much for listening to my presentation on my final year project. Once again, my name is Sylvester Didon Anajo. Thank you and have a good day.